Hello everyone. We were discussing the chapter, the PBlock elements. Okay. In PBlock elements, we started with the group 13 elements, that is the boron family. In that, we discussed boron and its compounds. Okay. The next important element in the PBlock family and the group 13 elements is aluminium. Okay. So I'm going to start with aluminium today. Okay. In studying aluminium, what we would see is the properties of aluminium, okay, and the compounds of aluminium, their properties and their preparations. Okay. So first of all, we would see the properties of aluminium. Okay. These properties of aluminium would include both physical and chemical properties. Okay. The first property is that aluminium is a silvery metal. Okay. You would find aluminium and the objects of aluminium you may find in some of your old utensils. Okay, initially the utensils were made of aluminium. Nowadays they are made of steel and plastic, but initially they were made of aluminium, and you may find it in your houses. Okay, now aluminium is a silvery metal. Okay, it is a silvery metal. It is a good conductor of heat and electricity. It is good conductor, heat and electricity. It is a soft metal. It is not very hard, and it is malleable and ductile. Okay, it is malleable and ductile. Okay, so these were the physical properties of aluminium. Okay, now moving on with the chemical properties. Okay, now the first chemical property is action of oxygen, that is O2. Okay, so what happens when aluminium reacts with oxygen? Now, oxygen is present in air. You know very well that. Now, what happens is that aluminium objects is when they are in constant contact with atmosphere, they react with the oxygen present in air and form a thin aluminium oxide layer. Okay, aluminium reacts with oxygen present in atmosphere to form Al2O3. Okay, balancing this reaction, we would write this. Okay, now this aluminium oxide layer, this is what? This is aluminium oxide. Okay, this is aluminium oxide. We would study aluminium oxide in detail in the next videos, but this aluminium oxide gets deposited on the surface of aluminium. Okay, now this aluminium oxide gets deposited on the surface of aluminium. Deposited on the surface of aluminium, gets deposited on the surface of aluminium and makes it passive. Okay, towards reaction with other substances. Okay, so what happens is that aluminium oxide layer is getting deposited on the surface of aluminium. So whenever you bring other substances in contact with aluminium for reaction, it is the aluminium oxide. Okay, it is the aluminium oxide which gets in contact instead of aluminium. Okay, so what happens is that aluminium does not react with the other substances, and it is rendered passive. Okay, so the next property which we would see is reaction with the property number 3. Okay, third property is action of alkalis. Now what are alkalis? Action with alkalis. Alkalis are NaOH, KOH. You know this very well. Okay. Now, aluminium is an amphoteric metal. It reacts with both acids as well as alkalis. Okay. So, aluminium reacts with alkali, which is NaOH is an alkali. So I would take NaOH. Okay. And water to form NaAl, NaAlO2 plus hydrogen. Okay. Hydrogen is liberated in this case. Okay. Now, this is the reaction for aluminium with alkali. Now, when aluminium, the fourth property, action of bases. Action of acids, sorry. Action of acids. Now, acids are H2SO4, HCl, etc. Now, when aluminium reacts with acids, again, aluminium plus H2SO4, okay, it forms Al2 SO4 whole 3 plus H2. Again, in this case also, hydrogen is liberated. Okay, balancing this reaction. Here it would be 3 and here it would be 3. Okay. Now in this case also hydrogen is liberated. One more example of this is 2 times aluminium reacts with 6 times HCl to produce 2AlCl3 plus H2. Again, in this case also hydrogen is liberated. Now, you can very well see that aluminium reacts with both bases and acids. So, due to this property, we say aluminium is amphoteric in nature. Okay? We say that aluminium is amphoteric. Okay? You write this down. Due to this property of reacting with both acids as well as alkalis, aluminium is amphoteric. Okay, so this is the reason why aluminium, we call aluminium as an amphoteric metal. Okay, now the next property which we would see is this would be property number 5. Okay, the fifth property is that reaction of aluminium with nitrogen. Okay, action of nitrogen, N2. Okay, now aluminium reacts with nitrogen to form aluminium nitride. Okay, aluminium reacts with nitrogen and forms AlN. Okay, this is aluminium nitride. This is aluminium nitride. Okay, the next property is property number 6, action of aluminium with water. Okay, action of water. Now, aluminium does not react with water, with cold water. Okay, it only reacts with boiling water or with steam. Okay, we would write reacts with only boiling water or steam, not cold water. Okay, Now when aluminium reacts with boiling water or steam, hydrogen is liberated, okay, and aluminium hydroxide is formed. 2Al plus 6H2O gives AlOH whole thrice, okay, plus H2. Okay, hydrogen is liberated in this case, balancing this reaction. Okay, hydrogen is liberated in this case, and aluminium hydroxide. Okay, aluminium hydroxide is formed. Okay, now the next property which we would see is reaction with halogens. Property number 7, action of halogens. In halogens we would see action of chlorine over here. Now when aluminium reacts with chlorine, aluminium chloride is formed. Aluminium plus Cl2 gives AlCl3. Okay, balancing this 2, aluminium chloride is formed. Now the structure of aluminium chloride is a bit unique. Okay, the structure of aluminium chloride is aluminium is over here, then chlorine, and then chlorine over here. The electrons are present. For aluminium, the electrons are here, here, and here. For chlorine, the electron presents are over here, and over here. Okay, so you can very well see that these are the 6 electrons present around aluminium. Okay, so aluminium contains total 6 electrons. Okay, now due to this, the octet of aluminium is not complete. Okay, the octet of aluminium is not complete. Octet of aluminium in AlCl3 is not complete, and AlCl3 is an electron deficient molecule. Okay, since the octet of aluminium is not complete, it requires 2 more electrons to complete its octet. Okay, since there were here 6 electrons, okay, here there were 6 electrons, so aluminium requires 2 more electrons to complete its octet. Okay, so it acts as Lewis acid and has a tendency to accept a pair of electrons. Okay, therefore it acts as Lewis acid. Okay, now the next property of aluminium is property number 8. Okay. Next property is reduction of oxides of metals. That is, aluminium also acts as a reducing agent. Metal oxides. Okay, so when aluminium reacts with metals which are less reactive than oxygen, okay, when aluminium reacts with metals which are less reactive than aluminium, metal oxides, then it replaces the metals with from their oxides and itself forms an oxide. Okay, like when aluminium reacts with magnesium oxide, okay, magnesium is less reactive than aluminium. Okay, in presence of heat, aluminium oxide is formed and we get magnesium. Okay, similarly when aluminium reacts with chromium oxide, okay, aluminium oxide is again formed and we get chromium. This also takes place in presence of heat. Okay, so what happens is that these metals, okay, these metals over here, these metals are less reactive than aluminium. Okay, so aluminium replaces them from their oxides, okay, and thereby reduces them. Okay, the charge on chromium here is +3, the charge on chromium here is 0, that is the oxidation state is 0, and here it is 0 and here it is +3. But similarly for magnesium, the oxidation here state here is +4 and here it is 0. Thereby you can see that the oxidation state decreases from 4 to 0 and decreases from 3 to 0. That is why this is called reduction. Okay, so that's all for this video lecture. In the next video I would be starting with the compounds of aluminium. Okay.